Welcome, young scientists. In this video, we'll see how to make accurate measurements. This here is a triple beam balance. It's used to measure mass. It's starting at 0, and the pointer is also at 0. When making mass measurements, you're going to place things onto this plate here, and then move the sliders here so that it reaches the 0. Here's the plate when it's empty, and here are the sliders. Now, when you make the mass of any type of measurement, you're going to add up all of the numbers on the sliders. So this is 10 plus 0 plus somewhere between 2 and 3. Let's take a closer look at the last slider. The last slider is actually showing 10 plus 2, so that's 12. So it's going to be somewhere between 12 and 13 grams. Now let's look here at these little tick marks. There are 10 tick marks here, so we will calculate this as 12.1, 2, and somewhere between 12.2 and 12.3. This here is right in the middle of 12.2 and 12.3, so we'll estimate that to be 12.25. With this balance, we're always going to measure to the hundredths place, so 12.25 is a good measurement to record. We know how to use the triple beam balance. Let's set up our data tables. We're going to have two data tables, one for still water and one for moving water. The still water versus the moving water is our independent variable. We have a blank here for the boat by itself, and then the candy plus the boat initial before we expose the candy to water, and the candy plus the boat final after we expose it to water. In the moving water, we still have the same measurements. Now we're ready to collect our masses. So the first mass here is just of the boat by itself. The second mass to record is of the dry candies plus the boat, and we'll take that mass and record it in the data table. The last mass to record is going to be the mass of the candy after exposed to water. So let's expose it to water. That means we're going to have to take some measurements of the water. To measure the volume of water, we're going to use a graduated cylinder. This here is a beaker, and I'm using the beaker to add water to the graduated cylinder so I don't splash or spill, and I make sure that the water is poured nice and smoothly. The other tool here is a pipette. We use the pipette in order to add water even more slowly. When we get to the volume of our desired amount, then we'll start using the pipette to add water. 60 is the volume of water that we chose in order to have it as a control variable. This graduated cylinder is measuring 60 milliliters of water. Make sure that you look at your graduated cylinder straight on, because if you look at it from below, it looks like a little bit less than 60 milliliters, and if you look at it from above, it looks like more than 60 milliliters. Also, when you look at the water here, the water will make a curve. This is called a meniscus. Because of surface tension, the water tends to stick to the edges of the graduated cylinder. This line here should be at the bottom of the meniscus, showing exactly 60 milliliters of water. Now we add the water to the jar, and then add the candy to the water, and then it should look like this. We're going to expose the candy to water for a certain amount of time. Each hui is going to expose their candy to water to a different amount of time. Hui 1 will expose their candy to water for 30 seconds, Hui 2 for 60 seconds, Hui 3 for 90 seconds, and Hui 4 for 120 seconds. This will come into play later when we combine the data, so we can actually see that if we increase the duration of time that the candy is exposed to water, we may hypothesize that more erosion will occur. After exposing your candy to water, put it on a paper towel and pat it to dry. Don't pat it too hard, otherwise the candy might break further. If you have any pieces of candy, make sure to put all of the pieces of candy onto the scale in order to mass it. Use the boat in order to do your mass measurements. And if you've been following along with the correct steps, you should have all three measurements: the boat by itself, the candy and the boat, and then after exposing it to water for the amount of time, you will have the mass of the candy and the boat final. When you're done with this side of the paper, then go ahead and fill in this side by collecting the mass of the boat and then the candy and the boat initial. Now this time you're going to expose it to water for the same amount of time, but shake it for the entire duration of the time you're supposed to expose it. Then take the final mass of the candy and the boat together. After you fill out your entire table, you're ready for our equations. Look at the equations recorded here. The candy and the boat's mass minus the boat's mass equals the candy's mass. That makes sense. The next thing you're going to do is you'll have two different candy masses, the final and the initial. So the candy's final mass minus the candy's initial mass is going to be the difference in mass after exposure to water. That is our mass of things that were eroded. This mass eroded here becomes the mass you transferred to the other table, and you're going to have two of them. One is going to be the mass right here of the still water. The other is going to be the mass of eroded things for the moving water, and you'll just have these two numbers. Now you can really look at your data and see if your hypothesis was supported and refuted. If the mass eroded of candy exposed to moving water is larger, then you can say your hypothesis is supported. Moving water does indeed erode rock more quickly. Curious about data from other lab groups, we're going to be able to average all the data from the other lab groups. And if you're curious to see what happens with other hui as we increase the time that water increase the time that candy is exposed to water, then you'll be able to even have more data. And the more data that we have to support our hypothesis, the stronger our support of the hypothesis becomes. Make sure you clean up when you're done. Wipe the counters from any water spills and make sure that nothing is sticky. Dry all of your glassware and make sure to throw away all of your trash. If you're curious to how we're going to analyze all of this data, stay tuned for the graphing video. You'll be able to determine how your data looks like across all of the other hui. We understand how erosion works. We can definitely really malama the aina and ho'ola la hui, because we're going to use science in order to make the world a better place for everybody. Good luck when you try this experiment on your own, and remember that science is everywhere.